Hey everyone, and welcome back for another deep dive.
It's great to be back.
So today, we're heading to the International Space Station.
Okay.
It's January 2025, and things are about to get really interesting.
Yeah.
We're going to be focusing on a recent NASA article. It details a spacewalk. But, and here's the twist, the astronauts are going to be searching for microbes.
Microbes in space.
Yeah. Microbe hunting in space.
Yeah.
We've got all the source material ready, so buckle up and get ready for a deep dive
Sounds fascinating.
into the science and the significance of this very unique mission.
You know, what I find really captivating about this mission is the sheer amount of research happening simultaneously on the ISS.
Yeah.
It really is like a beacon of continuous scientific exploration. And I think this spacewalk perfectly encapsulates that.
It really does. And speaking of exploration, this mission has some familiar faces at the helm.
Oh.
Station Commander Suni Williams
Okay.
and Flight Engineer Butch Wilmore.
Right.
They're overseeing all the prep for the spacewalk.
I see.
They're actually in the Quest airlock right now.
Wow.
Meticulously organizing every single tool.
That level of precision, I mean, that really speaks to just how high stakes the environment of space is.
Right.
Every tether, every single bag, even the foot restraints. It all has to be perfectly placed when you're working in a vacuum.
Yeah.
One misstep could have some pretty serious consequences.
Absolutely. And what's really interesting is that this spacewalk, it's not just about like routine maintenance. It's also about scientific discovery.
Okay, so let's talk about this microbe hunt then.
Yeah.
What makes these tiny organisms so important that we're sending astronauts on a spacewalk to find them?
Well, I think, to put it simply, understanding how microbes act in the harsh conditions of space is really crucial for a number of reasons.
Okay.
For one, it's vital for any future long-duration missions.
Right.
Like, imagine sending humans to Mars.
Yeah.
That's a journey that could take years.
Absolutely.
We need to know how these microorganisms might affect crew health.
And the spacecraft systems, especially during such a long and isolated trip.
That makes sense. But isn't microbe contamination more of a concern in a closed environment,
Yeah.
like a spacecraft, as opposed to the vastness of space?
That's a great question.
Yeah.
And the answer, well, it's kind of complicated.
Okay.
So while it's true that a contained environment
Right.
can foster the growth of certain microbes, exposure to the vacuum of space,
Right.
and the extreme temperatures and radiation could also lead to unexpected mutations or changes in their behavior.
Okay.
We need to understand the full range of possibilities if we're going to be adequately prepared.
I see. So we really wouldn't want any unexpected microbial surprises on a mission to Mars.
Exactly.
Yeah.
So, besides all the practical considerations for human spaceflight,
Right.
there's actually a much bigger picture here.
Absolutely. So studying microbes in space offers a unique window into the potential for life beyond Earth.
Okay.
The discovery of extremophiles.
Organisms that thrive in extreme environments here on Earth. I mean, that has already revolutionized our understanding of where life can exist.
Right. Right.
What if we find evidence of microbial life on the exterior of the space station?
Yeah.
Exposed to the vacuum of space. It really expands our understanding of life's resilience and the possibility of life existing elsewhere in the universe.
It really does. It's like this cosmic game of hide and seek, but instead of finding a friend, we're potentially discovering brand new forms of life.
That's amazing.
I know. And it's all happening right now as we speak.
Wow, that's incredible. And, while Suni and Butch are prepping for their spacewalk,
Right.
other astronauts are conducting equally fascinating research.
Yeah.
Hague, for instance, is working on a space navigation project
Oh.
using something called NAVCOM.
NAVCOM. Okay. Yeah. So this NAVCOM,
Yeah.
is it like a potential alternative to GPS?
It is. Think of it as a system that would allow spacecraft to navigate autonomously, even when they're beyond the reach of GPS signals.
Wow.
This is especially crucial as we look towards lunar missions and deep space exploration.
That is remarkable. It's like we're building the tools for a whole new era of space travel. And it's all happening alongside these other experiments.
Speaking of cutting-edge research,
Yeah.
Pettit is doing some groundbreaking work with DNA sequencing.
Really?
Yeah, he's analyzing bacteria samples from the station's water system.
Okay.
And what's really fascinating is that he's able to identify different types of microbes in real time.
Wait, they can do DNA analysis in space?
Yep.
I thought that type of technology was limited to, labs here on Earth.
That used to be true.
Yeah.
But recent advancements have allowed them to create smaller, more adaptable tools that can be used in space.
That's a game changer.
It really is.
Yeah.
It's essential for monitoring true health, being able to identify harmful bacteria, and taking steps to prevent outbreaks.
So it's basically like having this high-tech health monitoring system built into the space station.
Exactly.
That's pretty incredible.
It is.
And this DNA sequencing, it's not just sci-fi anymore, is it?
It's not, you see similar techniques being used in healthcare here on Earth.
Okay.
It's a perfect example of how space exploration drives innovation in other fields.
It's amazing to see how all of these different research threads are connected, from understanding the potential for extraterrestrial life to protecting astronaut health.
Yeah.
It all comes back to this overarching goal of expanding the boundaries of human knowledge.
It really does.
Yeah.
Yeah, it really highlights the interconnectedness of scientific exploration.
Yeah.
Discoveries made in space, they often have direct applications here on Earth and vice versa, research on Earth, that can inform our understanding of the cosmos.
Right.
It's this constant feedback loop of knowledge and innovation.
Speaking of innovation, let's go back to that meticulously planned spacewalk for a second.
Okay.
Suni Williams and Butch Wilmore.
Yeah.
They aren't just organizing tools.
Right.
They're also going through the procedures in incredible detail.
I see.
Can you give us a sense of what that might look like? The level of precision involved?
So just imagine yourself tethered to the space station.
Okay.
Hundreds of miles above the Earth.
Wow.
Below you, you see the curve of our planet.
Yeah.
And all around you is the vastness of space.
Right.
Every movement has to be calculated, every tool secured.
Yeah.
They're essentially operating in a vacuum.
Right.
Where even a small mistake could have serious consequences.
I can't even imagine the mental focus that must require.
Yeah.
And, it's not like they're just tightening bolts out there.
Right.
They're actually removing a critical piece of equipment.
Yeah, the radio frequency antenna assembly.
Okay.
They're detaching it. It's vital for communication with Earth.
Wow.
It's a really complex operation.
Yeah.
Demands steady hands and a deep understanding of all the station systems.
And then there's the microbe collection. How do they even go about collecting these microscopic life forms in the vastness of space?
Yeah.
It's not like they're carrying around these tiny Petri dishes or anything.
Well, not quite. They're using these specialized sampling devices to swab various surfaces on the station's exterior.
Okay.
Basically any area where microbes might be able to survive.
So they're looking for those microbial pioneers who've decided to make the space station their home.
Exactly.
It makes you wonder what kind of adaptations those spacefaring microbes might have developed.
That's a great question, and it's one of the most intriguing things about this research.
Yeah.
I mean, think about it. Exposure to the vacuum of space, extreme temperatures, constant bombardment from radiation.
Yeah.
If these microbes can survive all of that, they've probably developed unique ways to cope with these conditions.
It's like they're evolving right before our eyes.
Yeah.
Adapting to this completely alien environment.
Right in front of us.
Yeah. A real-time evolution experiment happening in space.
Pretty amazing.
I know. What happens to those samples once they're collected?
So some will be returned to Earth for in-depth analysis.
Okay.
But remember, Don Pettit,
Yeah.
he's already doing real-time DNA sequencing on the ISS.
Right?
They have the capability to analyze some samples right away.
Wow.
Which could provide invaluable insights and inform future research.
So we have this immediate analysis.
Yeah.
And the potential for even more detailed study back on Earth.
Exactly.
It's this multifaceted approach to understanding these space microbes.
Yeah, that's what makes this research so exciting.
Right.
It's pushing the boundaries of what's possible in terms of technology and scientific understanding.
It strikes me that this whole mission, from the spacewalk to the DNA sequencing, even the NAVCOM project, it's all about pushing the limits of human knowledge.
It really is.
It's about exploration in the truest sense.
Absolutely.
It's answering those really fundamental questions about life, the universe, and our place in it all.
And the ISS, with all its capabilities, I mean, it's a truly remarkable tool for satisfying that human curiosity.
It's like we're constantly pushing the boundaries of what we thought was possible. Just a few decades ago, the idea of hunting for microbes on a space station would seem like pure science fiction.
Absolutely.
And now it's reality.
And the pace of discovery is only accelerating.
Yeah.
Think about the technological leaps we've made just in recent years.
Right.
I mean, imagine what the next decade will bring.
Wow.
What new wonders will we uncover? What mysteries will we solve?
It's pretty mind-blowing. But we can't forget about the present.
Yeah.
We have this incredible spacewalk happening soon.
That's right. The spacewalk is scheduled for January 30th.
Okay.
And you know what? Those who are interested might actually have the chance to watch it live. Yeah. It's not every day you can see astronauts going out into space to hunt for microbes and upgrade those critical systems.
I'm definitely marking my calendar for that.
Good idea.
It's a chance to see history being made, to see science in action in the most extraordinary setting imaginable.
It's amazing.
But before we get lost in the excitement of the spacewalk, we can't overlook the contributions of the other crew members on this mission.
Oh, yeah, you're absolutely right.
Expedition 72.
Each astronaut is playing a vital role.
So, for example, we have Alexei Ovchinin, who is focusing on spacecraft operation. Can you tell us a bit more about that?
Sure. So, Alexei's work is crucial for future planetary missions.
Okay.
He's using a special cap fitted with sensors and computer simulations to research how astronauts might operate spacecraft and robots in the challenging environments of other planets.
So he's essentially laying the groundwork for future space exploration, helping us prepare for the complexities of navigating and interacting with alien worlds.
That's right.
That's amazing.
It is.
And what about Ivan Wagner?
Yeah, so Ivan is playing a key role in maintaining the functionality of the station.
Okay.
He's currently servicing all the electronics hardware in the Zarya module, making sure all the systems are running smoothly.
You know, it's easy to get caught up in the excitement of the spacewalk and the cutting-edge research. But without people like Ivan diligently working behind the scenes, none of this would even be possible.
Couldn't agree more.
And lastly, we have Alexander Grabunov.
Yes.
What is he focusing on?
Alexander is using specialized cameras in the Zvezda service module to capture special images of Earth.
Oh, wow.
These images provide data that help scientists study the effects of disasters on our planet.
That's fascinating.
It is.
So while they're orbiting Earth, they're also contributing to our understanding of events happening right here on the ground.
Exactly. It really shows that connection between space exploration and Earth science.
It really does.
The data gathered from space gives us this unique perspective on our planet.
Yeah.
It lets us study large-scale phenomena and helps us understand how Earth's systems are all interconnected.
It seems like every aspect of this mission, from the microbes to the images of Earth, it's all about expanding the boundaries of human knowledge and understanding.
It really is a testament to human curiosity and our pursuit of knowledge.
Yeah.
Each experiment, each observation, even the spacewalks, they all contribute to this larger tapestry of understanding, weaving together science, technology, and the human spirit of exploration.
This has been an incredibly enlightening deep dive so far.
It has.
We've covered so much. The spacewalk preps, the scientific goals, the tech advancements, and even the broader implications for our understanding of life and the universe.
And we're not done yet. There's one more really fascinating piece to this spacewalk that we need to explore.
All right, you've piqued my curiosity.
Good.
What else is there to uncover about this mission?
Well, you know, you mentioned earlier that this spacewalk, it has two main objectives. Removing that old antenna and collecting those microbe samples.
Exactly.
And we've talked a lot about the why behind that microbe hunt.
Yeah.
But I'm curious about the how.
Okay.
What's the process for actually collecting those samples, you know, out there in the space environment?
It's a really carefully planned procedure.
Okay.
It highlights the ingenuity needed for space exploration. The astronauts are going to be using a variety of specialized tools, including robotic arms with collection tools and sampling devices that can swab surfaces for any microbial traces.
So it's not as simple as just reaching out and grabbing some space dust.
Quite.
These tools are specifically designed to capture those microscopic life forms that might be clinging to the station.
Exactly.
And once the samples are collected,
how are they stored?
They'll be put in sealed containers to make sure they stay intact until they can be analyzed. Either on the ISS or back here on Earth.
It's just fascinating to think about those microbes potentially holding secrets to survival in the harshest environments.
I know.
It really does challenge our understanding of life and its boundaries.
It raises so many questions, doesn't it? Like, if we find microbial life thriving in the vacuum of space, exposed to those temperatures and radiation.
Right.
What does that tell us about the potential for life on other planets and moons?
It's like we're getting this glimpse into the vast possibilities for life in the universe.
Absolutely.
And that brings us back to something you mentioned earlier about the search for extraterrestrial life.
Right.
How does this microbe hunt on the ISS connect to that larger quest?
Well, the discovery of extremophiles.
Yeah.
Organisms that survive in these really inhospitable environments here on Earth. That has really changed our understanding of where life can exist. So this microbe hunt on the ISS, it's kind of like an extension of that search.
Okay.
Taking it beyond Earth's atmosphere.
So by studying these spacefaring microbes, we're gaining insights into the potential for life in other parts of the universe, places we once thought were barren.
Exactly. It's about expanding our definition of what's possible.
Right.
Recognizing that life might exist in forms and in environments that we haven't even begun to imagine.
It's incredible to think that this spacewalk, this seemingly routine maintenance operation, could have such profound implications for our understanding of life.
It shows that scientific exploration, it's really a journey into the unknown, full of unexpected discoveries and shifts in our thinking.
It's amazing, and for those of us following along from Earth, it's a chance to witness history in the making.
Exactly.
You mentioned that the spacewalk might be broadcast live.
It is. It's scheduled for January 30th.
Okay.
And, space enthusiasts, they'll probably be able to watch it as it happens.
Wow, what an opportunity to actually see those astronauts going out into the vacuum of space. To conduct this multifaceted mission. Combining essential maintenance with groundbreaking science.
I know, it's a really special moment. It captures the spirit of human ingenuity. Our drive to explore. To understand. To push the boundaries of what we think is possible.
Well, I think we've given our listeners a truly incredible deep dive into this mission.
We have.
We've covered the preparations, the scientific goals, the tech advancements, and even the broader implications for our understanding of life in the universe.
It's been an amazing journey.
It has.
Through the world of space exploration. Highlighting the connection between science, technology, and the human desire for discovery.
It really leaves us with this one big question.
What's that?
What will we find?
When we analyze those microbe samples, what secrets of survival do they hold? And what will their very existence tell us about the vast tapestry of life in the cosmos?
Those are the questions that will drive future research. And as we keep venturing out into space, who knows what other wonders are waiting for us?
Well, on that note of cosmic curiosity, we'll wrap up this deep dive.
Sounds good.
We hope you enjoyed this journey to the International Space Station and beyond.
It's been a pleasure.
Until next time, keep exploring, keep questioning, and keep looking up at the stars.